Every so often an AI model comes along that just sends shockwaves through the whole community. Well, recently one did just that, claiming to be inspired by the human brain itself. But as we're about to see, the real story behind its incredible success, well, it's not at all what it seemed at first. Let's dive in and find out what's really going on.
So the story kicks off right here. This is the ARC-AGI reasoning benchmark, and it is notoriously difficult. A brand new model called HRM didn't just show up to compete. It absolutely smashed some of the biggest names out there, including Claude 3.7. And look at that gap. It wasn't even close. It was this stunning result that had everyone asking the same thing. How on earth did they do that?
And then came the fact that just blew everyone's mind. This powerhouse model, it has only 27 million parameters. Now, to put that into perspective for you, the models it was crushing have billions, sometimes even trillions of parameters. This is the equivalent of a go-karts not just competing with a Formula One car, but actually winning the race. It just shouldn't be possible. So that's the billion-dollar question, right? How did this tiny little model, trained on just 1,000 examples, pull this off? Well, the initial answer, the one that got everyone so excited, was a revolutionary brain-inspired design.
Okay, so let's start with that official story, the one that captured everyone's imagination, this so-called brain-inspired blueprint.
So this thing is called the Hierarchical Reasoning Model, or HRM for short, and its own creators described it as a totally new kind of architecture, one that was directly inspired by the way our own brains process information, on different levels and at different speeds. And you can see that core idea right here. On the left, that's the biological inspiration, the complex layered structure of a mouse's cortex. And then, on the right, you see how the HRM model was actually designed to copy it, with these separate parts that are supposed to think in different ways. So here's how it was supposed to work. First, you've got this slow, high-level module that's like the big picture planner. Then there's a fast, low-level module that's the workhorse, crunching all the nitty-gritty details. And the real magic, supposedly, was that they talk to each other in these loops, letting the model refine its answer over time, almost like it's really thinking a problem through. It was a beautiful theory.
But you know how these things go. A few curious people decided to pop the hood and take a closer look. And what they found? Well, it changed the entire story. And this right here, this quote is the moment the plot takes a hard left turn. The ARC Prize team, these are the official keepers of the benchmark, they ran their own analysis. And this quote says it all. They found some things that made them question that whole brain-inspired narrative. So think of these guys as our detectives in this story. They took the actual code for HRM and went on a mission to figure out what was really going on. Was this brain-like architecture truly the secret sauce, or was it something else entirely? And what their investigation uncovered was that the real reasons for its incredible performance were actually hiding in plain sight the whole time. Okay, so this is where the myth really starts to crumble. The team asked a very simple question. Was that special, fancy architecture really the key? And their finding was just stunning. They swapped out HRMM's unique design for a standard off-the-shelf transformer of the same size, and it performed almost as well. The special sauce wasn't the architecture. Wow, okay, that changes everything. If the brain-inspired design wasn't the main reason for its success, then what in the world was? Well, it turns out the investigation pointed to two other hidden drivers. The first major driver was something they called the outer refinement loop. Honestly, the easiest way to think about this is that the model is proofreading its own work. It spits out an answer, then it takes that answer and feeds it back into itself to check it, correct it, and make it better. Over and over. And the impact of that little self-correction trick is absolutely staggering. Just look at this chart. With one pass and no refinement, the model's performance is okay. But add just one more round of that proofreading, and its performance jumps by a massive 13 percentage points. This iterative process was a huge part of the secret.
Now, the second key driver was something called data augmentation. This is a pretty common technique in AI, actually. You just take the training data you have and you create more of it by making simple little changes. You rotate an image, you flip it, you change the colors. It helps the model learn the general idea behind a puzzle, not just memorize one specific version of it. But here is the real kicker. The original paper used 1,000 of these augmented examples. The analysis found you could get almost the exact same level of performance with just 30. That's only 3% of the data to get 96% of the result. It just shows how incredibly efficient this kind of training can be if you do it right. So what does this all mean? The story completely changed, right? It went from being about a magic architecture to just really, really clever engineering. And this shift points toward a very different and maybe even more exciting future for AI. And this quote from the YouTube channel Discover AI just nails the implication here. The big takeaway from this whole HRM saga isn't about building one single, giant, all-powerful brain. It's about the very real possibility of creating tiny, super efficient, specialized AIs that can run on a regular laptop.
And this really clarifies the two different paths AI development is on right now. For years, the race has been all about building these massive, incredibly expensive generalist models like GPT-4 that are pretty good at everything. But the real lesson from HRM seems to point down a different path, creating tiny, efficient models that are absolutely world-class at doing one specific thing. I mean, this new approach just opens up so many possibilities. Think about it. You could build these hyper-focused expert AIs tailored for very specific tasks inside a company. They could run on local hardware, which is cheaper and way more secure than the cloud, and on that one narrow task they were built for, they could actually outperform the giant general-purpose models. Which leaves us with this final thought. Maybe this whole quest for artificial general intelligence has had us all looking for a single, all-knowing artificial brain. But perhaps the real future of AI, well, maybe it looks more like a team. 1 million tiny, brilliant experts, each one perfectly designed for the job at hand.